Hey, this is Andrew Brown from Exam Pro, and in this follow along, I'm going to show you how to set up your own Kubernetes cluster for development using a lightweight Kubernetes distribution. So Kubernetes generally is very hard to deploy, and most people, for general use case, do not set up their own clusters for production. What they'll do is they'll use a managed provider like AWS's EKS, which we might do throughout this course. I haven't decided yet, but if it does show up, that might be something we do. But that can be really expensive because you have to pay for the control plane. Almost all providers charge for the control plane. The control plane node, as we learned throughout this course, is a node specifically intended to orchestrate and coordinate all your worker nodes and the pods and everything. So it's like the brain of Kubernetes. And on AWS, at least, it's 10 cents an hour. So there are providers like Sivo. And so Sivo is actually very cost effective. Pricing comparison. I wonder if they have it here. So if we go here, they might actually compare the different prices between other providers. So Sivo, the control plane is free. And this is a guess, right? And this is at scale. So if you're using this for learning, like if you made a Sivo account, they'll give you $250, I think, for to start with. And for this course, you will not end up spending all of that. So if you are really strapped, you could use Sivo. I'm going to be using AWS, but we aren't going to be launching EKS right now. What we're going to be doing is launching a virtual machine so that it's only the cost of the virtual machine that we're paying. If you really have zero money, another thing you can do is use Catacota. So Catacota is a sandbox environment by O'Reilly. And so they have this section on Kubernetes introduction. It is not sufficient enough for this course, but I'm just pointing it out. If you are very, very strapped but you want to get some hands-on, this is an option for you. I would not recommend doing this as your as first, because the problem with sandboxes is that you aren't going to experience the hard bits. And the hard bits is the experience that you're trying to obtain. If you go do these, you're going to follow them blindly, copy, paste them. And the problem with that is that you're just not going to absorb any information. But I want to make sure that you're aware of these resources. This would be good for drilling. So after our follow-alongs, if you wanted to just make sure that you cement that knowledge, you could go back here and try Catacota. But I think we really should set up our own cluster. So we have a few options. We have Minikube, Kind, K3s, and Micro K8s. And so there are 4 different ones, and they are all a little bit different. So Minikube is known for being extremely easy to use, but it requires the most resources. Notice it requires 2 gigabytes of memory, 20 gigabytes of free disk space, but they all kind of require at least 10 gigabytes. Then you have K3s and Kind. So K3s and Kind are essentially the same thing, but Kind is it has a wrap around it so that you can deploy your cluster onto Docker. And so Kubernetes K3s is designed to be directly on bare metal or virtual machines, as you see, Edge, IoT, whatever. This is made by Rancher. So Rancher is a company that provides Kubernetes managed services. And the thing is that K3s is not, or like Rancher's version of Kubernetes is not the same as Kubernetes. It's not vanilla Kubernetes. You'll see components in the control plane here like Kind and Flannel. These things don't exist in Kubernetes, so there's something slightly different here. So there's that. And then we have Kind, which is, again, it's like K3s. It's just wrapped in Docker. So you can see the little boat here to emphasize that. And there's Micro K8s. So Micro K8s is by Canonical. If you don't know Canonical, they're the ones that create and manage Ubuntu. And so it's actually really easy to launch Micro K8s on an Ubuntu machine, surprisingly, because it uses Snap. But what's nice here is they actually will compare the difference between Micro K8s, K3s, and Minikube. And now I said K3s is basically Kind, so just substitute that with Kind, because we're not going to do K3s, we're going to do Kind in these follow-alongs here. But let's just look at some of the comparisons. So vanilla Kubernetes. So K3s is not vanilla. As we saw in that diagram, they had things that were slightly different that made up a different kind of control plane. They mostly support the same things, but here you can see the memory requirements. Micro K8s requires the least amount of memory. Minikube requires the most amount of memory. Then we have add-on functionality. So Micro K8s is very, very plug-in driven. So like it comes with nothing and you have to add everything. It's very modular, and that's probably why those memory requirements can go lower than those other ones. Minikube is kind of like that as well. K3s, you just get what you get, or Kind. Then there's different container runtimes that you can run on different ones. There's different networking components that work with them. Storage is a bit different. GPU acceleration is if you would want to do like something like machine learning, because you can run machine learning workloads on Kubernetes. There's a project for that. I can't remember it off the top of my head. So you can see there's kind of a difference there, but they all generally kind of work the same. And it's going to be up to you to decide which one you like to use. I end up using Minikube quite a bit, but I generally like Micro K8s when I can get it to work. So just because it starts up so fast. But yeah, Minikube takes the longest to boot. Kind is very fast because it's in Docker, and then Micro K8s is like instant, which should be no surprise here. But what we'll do here is we'll make our way over to AWS. And before we can even run any of these things, we're going to have some kind of application to deploy. And so what we'll do is we will create ourselves from scratch. I'll show you how to do it. A Docker image, and we'll host that somewhere in a container repository. And we will use that as the thing that we will run in all these different lightweight containers. And so that's what we're going to do now, okay?